and I'm going to take you through the integumentary system. The integumentary system is the organ system that protects the body from various kinds of damage, such as loss of water, which can be termed medically as dehydration, then abrasion, or what we can term as injury. The system comprises of the skin and its appendages, hairs, scales, feathers, and the nails. Functions of integumentary system. It serves as waterproof, that is because it contains the fibrous protein, i.e. keratin and the other proteins and lipids, so can protect the body from water. It acts as a cushion because it has the adipose tissue. Remember, we talked about the adipose tissue and we said that it is in which fats are deposited. We have the white and the brown adipose tissue. So it acts as a cushion in the body. Then protects the deeper structures, excretes waste uh, such as through sweat. Then regulates body temperature, that is through vasoconstriction and vasodilatation. Protects the deeper structures, excretes waste through sweat, then regulates body temperature through vasoconstriction and vasodilatation. Also sensation, because they have the nerve endings in them, so they can help to detect pain, pressure, and temperature. Then vitamin D synthesis through the skin, then gaseous exchange by diffusion. So let us look at the chapter objectives. At the end of this chapter, the students must be able to describe skin of the human body, discuss glands of the skin, explain the structure and the functions of the skin, discuss about the skin appendages. So right there we have a pictorial which shows us the skin and the different layers, and in it also germinates the hair, and right there we have the hair shaft. So you can look at it closely to see those structures and understand them. The skin is the largest and heaviest single organ of the body. That is because it covers the whole body and it accounts for about 16% of total body. It is composed of the epidermis, the dermis. Beneath the dermis lies the hypodermis. Based on the comparative thickness of the epidermis, thick and thin skin can be distinguished. Epidermal derivatives include hairs, nails, and sebaceous and sweat glands. The external layer of the skin is relatively impermeable to water. This prevents water loss by evaporation. That is why water can be able to be contained in our bodies for very, very long period of time. So glands of the skin, blood vessels, and adipose tissue participate in thermoregulation, body metabolism, and the excretion of various substances. Because skin is elastic, it can expand to cover large areas in conditions associated with swelling, such as edema and pregnancy. So the skin is elastic. In case of any swelling, it will uh, adjust, it will stretch and adjust according to the situation. That's why when a woman is pregnant, she does not burst. The skin stretches and accommodates the pregnancy. So upon close observation, certain portions of human skin show ridges and grooves arranged in distinctive patterns. The patterns assumed by ridges known as dermatoglyphics. They are unique for each individual, appearing as loops. These configurations are used for personal identification, or what we can say as fingerprints. That's why when you go for your ID or nationality, you will have to press your fingerprint. This is because fingerprints can never be the same. So the fingerprint for one person is only for that person. The human skin is composed of three layers of tissue, that is the epidermis, dermis, and the hypodermis. Let us look at the epidermis. This is the top layer of the skin. It does not contain blood vessels. It's composed of stacked cells called squamous cells. Cells found in the epidermis, we have the keratinocytes, melanocytes, Merkel cells, Langerhans cells. Then, those are the cells. So let us start looking at them one by one. We start with keratinocytes. Keratinocytes produce keratin, or in brackets, fibrous waterproof protein. Keratin is a key component of hair and nails. Most of the skin is keratinized except lining of skin inside mouth. Then melanocytes produce melanin, that is the dark pigment, or stroke the skin pigment. So for instance, the colored people of color, we have lot of the melanin, and this gives us the dark color of the skin. Then the Merkel cells are involved in touch reception. Langerhans cells help the immune system fight antigens or foreign bodies. Layers of the epidermis. It has 5 layers, namely stratum, stratum basale, stratum spinosum, stratum granulosum, stratum lucidum, then the stratum corneum. Stratum basale, it is the deepest layer. The stratum basale consists of a single layer of columnar or cuboidal cells resting on the basement membrane at the dermo-epidermal junction. So this is the basal, or the base layer of the epidermis. It's the one that is at the bottom. The stratum basale contains stem cells and is characterized of intense mitotic activity. Division of the cells takes place at that point. It is responsible for constant renewal of epidermal cells. Skin cells germinate here, hence the word germinativum. Keratinocytes arise from here. Millions of cells arise from here and they are pushed up into the upper layers. As these cells move up toward the surface, they change their shape, nuclei, and the chemical composition to make sure that they fit the function that they are going to play, or the role that they are going to play in the body. So right there we have that pictorial even there. So let us look at layers of the epidermis as a continuation. So stratum spinosum. From the stratum basale, the keratinocytes move into this layer, forming keratin bundles, or what we can call filaments. These keratin bundles, visible under the light microscope, are called the tonofilaments. The filaments play an important role in maintaining cohesion among cells and in resisting the effects of abrasion. This layer is responsible for the skin's strength and flexibility. Stratum granulosum consists of 3 to 5 layers of flattened cells. Cells here contain many granules, hence the name. Gran- uh, Hence the name. Granules are called keratohyalin granules. Keraton Keratinocytes produce a lot of melanin in a process called keratinization, and it has a membrane-coated lamellar granule, which are formed by lipid bilayers. The lipids act as a barrier towards the external environment, and so it is what provides most of the protection to the skin, to the body. Stratum lucidum. Once the keratinocytes leave stratum granulosum, they die and help form stratum lucidum. Death is due to the far distance between the keratinocytes and the rich blood cells of the stratum basale. Hence, they are devoid of oxygen and nutrients. The dead cells are pushed towards the surface of the skin. The stratum lucidum gives a clear, transparent appearance, under a microscope. So when studied under a microscope, it appears clear or transparent. Stratum corneum, it is filled with conified cells. It can be seen with our eyes. Contains dead cells. The dead cells, the ones that we described above, are the keratinocytes. Here are called coniocytes, devoid of water and nucleus, filled with keratin. Coniocytes serve as a hard protective layer against trauma, such as abrasion, light, heat, chemicals, and microorganisms. So it is what gives protection to the body. Cells are surrounded by lipids that repel water. Coniocytes eventually shed into the environment and become part of dandruff in our hairs or dust. This entire cycle from new keratinocytes in its stratum basale to dead cell flaked off into the air takes 25 to 45 days for it to be complete. Let's look at the dermis. The dermis is a layer of skin between the epidermis and the subcutaneous tissues that primarily consists of dense, irregular connective tissue and cushions the body from stress and strain. It's divided into two layers: superficial, or what we can say capillary region, and the deep, thicker area which can be known as reticular dermis. The dermis is tightly connected to the epidermis through the basement membrane. Structural component of the dermis. It is composed of the collagen, elastic fibers, and the extra fibrillar matrix. Then also mechanoreceptors, which provide sense of touch. That's why when you're touched, you can feel on your skin. Thermoreceptors, which provide sense of heat. That's why you can be able to detect temperature. Then hair follicles, sweat glands, sebaceous glands, apocrine glands, lymphatic vessels, and the blood vessels. Blood vessels provide nutrient and the waste removal. Cells of the dermis. We have the fibroblast, the fibroblast synthesizes the extracellular matrix and collagen and plays a role in wound healing. Then macrophages is a type of white blood cells that digest foreign bodies. For example, cancer cells and the pathogens that invade the body. So they are part of the immune system to protect the body. Then we have the adipocytes. Here we have the what and the but. All of them can be under the white and the brown fat. So what is major component of skin oil and what is responsible for it? It's the uppermost, the dermis. We continue the layers of the dermis. It's the uppermost layer. It's composed of fine and loosely arranged collagen fibers and areolar connective tissue. It's named for its finger-like projections, that is, papillae that extend towards the epidermis. Then contains terminal network of blood vessels and mucinous corpuscles, or in brackets what we can say that mechanoreceptors responsible for light touch, because they have highest sensitivity or low threshold. So any simple touch, anything that falls on the skin, they can be able to detect it. Then we have the reticular dermis, lower layer found under the papillary dermis, composed of dense, irregular connective tissue of densely packed collagen fibers. It is the primary location of elastic fibers. It houses roots of the hair, sebaceous glands, sweat glands, and receptor nails. Orientation of collagen fibers creates lines of tension called the Langer's lines, which are of relevance in surgery and wound healing. Incisions made parallel to Langer's line heal better and produces less scarring than those cut across Langer's line, e.g. keloids. So those that are cut across Langer's line can sometimes end up with complications, or they take long to heal. But if the Langer's line is followed, in most cases the healing is not a problem. Sweat glands are small tubular structures of the skin that produce sweat. These are a type of exocrine gland, or we can say secrete substances by way of duct. So there are two main types of sweat glands that differ in structure and function, viz. Eccrine and apocrine sweat glands. So the eccrine glands are distributed almost all over the human body. Its water-based secretions helps in cooling of the human body. Then the apocrine glands are mostly limited to axilla, or the armpits, and the perianal areas in humans. They are not significant in cooling in humans. Ceruminous glands produce earwax. Mammary glands produce milk, and ciliary glands produce tears, are all modified apocrine sweat glands. So these glands are modified, they are found in specific areas, but the exocrine are the ones that are responsible for cooling of the body. When temperatures are hot, they allow the sweating of the body so that the body can cool down later. Eccrine sweat gland. The skin contains 3 million sweat glands, which are found all over the body. Sweat glands are simple tubular glands. The secretory tubules and the initial part of the excretory duct are coiled into a roughly spherical ball at the border between the dermis and the hypodermis. The secretory epithelium is cuboidal or low columnar. Two types of cells may be distinguished. We have the light type, which secretes. We have the light side. We shall look at that into details. So contractions of these cells helps to discharge the secretion. The fluid secreted by sweat glands is not viscous and contains little protein. Its main components are water, sodium chloride, urea, ammonia, and uric acid. Cells present in the sweat glands, in the sweat ducts, are responsible for sodium absorption to prevent excessive loss of these iron. So, one much as water is lost out, at least the sodium ion is retained so that the person does not lose much of it. So glands duct empty directly onto the surface of the skin. Apocrine sweat glands occur in, for example, the axilla. They are stimulated by sexual hormones and are not fully developed or functional before puberty. Apocrine sweat is a milky, proteinaceous, and odorless secretion. The odor is a result of bacterial decomposition and is, at least in mammals other than humans, of importance for sexual attraction. So in animals such as the goats, the odor that is produced because of such kind of sweat is a capacity for sexual attraction, but in human, I think it is not a capacity for that. Secretory epithelium consists of only one major cell type, which looks cuboidal or low columnar. The excretory duct of apocrine sweat glands does not open directly onto the surface of the skin. Instead, the excretory duct empties the sweat into the upper part of the hair follicle. Sebaceous gland. These are microscopic exocrine glands that secrete an oily or waxy matter called sebum to lubricate and waterproof the skin. Sebaceous glands empty their secretory product into the upper parts of the hair follicles. In humans, they occur in the greatest number of the face and the scalp, and on all parts of the skin except palms and the soles of feet. Overactivity of this gland could result in medical conditions such as acne, sebaceous, and many others. And normally this appears on people's faces where you can see the person has lots of acne. It's because of the effect of or overactivity of the sebaceous glands. Vessels of the dermis. Blood vessels is providing nourishment and waste removal. Lymphatic vessels protects the body from infection by fungi, bacteria, and viruses, then the cancer. Let's look at the hypodermis. The hypodermis is the innermost and thickest layer of the skin. It is composed of a type of cells specialized in accumulating and storing of fats, which is known as the adipocytes. It acts as energy reserve because of fat storage, plays a role in thermoregulation, Fat is a heat insulator. Hypodermis accumulates above the belt region and shoulders in men. The reason for broader shoulder in men. That is why the men have broader shoulders, whereas the women do have narrower ones. And in women, about below the waist, around the thighs, hips, and buttocks. And that is the reason to why these areas in women appear to be wider or broader than in men. Fibro, let us continue by looking at the cells of the hypodermis. The cells of the hypodermis include fibroblasts, adipose cells, then macrophages. Skin color. Human skin shows high skin color variety from darkest brown to lightest pinkish white hues. Skin pigmentation regulates amount of UV radiation penetrating the skin and controlling its biochemical effects. Skin pigments are melanin, brown in color and present in basal layer of skin of epidermis, but is absent in albinos. So albinos do not have the melanin. That's why their color is a little unique. And we have the melanoid, resembles melanin but is present diffusely throughout the epidermis. Then we have the carotene. This pigment is yellow to orange in color, present in stratum corneum and the fat cells of dermis and the superficial fascia. Then we have the hemoglobin, found in blood, is not a pigment but develops a purple color. Clinical conditions of skin. Skin cancers. This is due to development of abnormal cells that have the ability to spread to other parts of the body. Then acne is due to overactivity of the sebaceous cells, glands. I had mentioned that before. Then pimples are due to excess oil getting trapped in pores, thereby harboring bacteria, causing infection and inflammation. And skin infections could be caused by bacteria, virus, fungus, and or parasites. Albinism, characterized by absence of skin pigment, inability of melanocytes to synthesize melanin. Let's look at the hair. This is a protein filament that grows from follicles found in the dermis or skin. It is composed of keratin. It has two parts, namely hair follicles and the shaft. Each hair follicle has an associated bundle of smooth muscle, the arrector pili muscle. Hairs are lost and replaced by new ones. Hair growth is controlled by a number of hormonal and hereditary factors and their interactions. A cross-section of hair is made up of the medulla, cortex, and the cuticle. Medulla is the innermost region, is not always present, and is an open, unstructured region. Cortex is the middle layer, is highly structural and organized. It's the primary source of mechanical strength and water uptake and contains melanin. Then the cuticle is the outer covering, is a complex structure which is covered with a single layer of lipid that repels water. So other structures of the hair include sebaceous glands, which lubricates the hair, then erector pili muscles, which are responsible for causing hairs to stand up or goose pimples. Also when it is cold or when someone has fear. Hair color. All natural hair colors are a result of two types of hair pigment. We have the melanin and the pheomelanin. Both of these pigments are melanin types or produced inside the hair follicles. Melanin is dominant pigment in brown hair and black hair. Pheomelanin is dominant in red hair. Blonde hair is a result of having little pigmentation in hair strand. Then the gray hairs occur when melanin production decreases or stops, and this is majorly during old age. Functions of hair. One is protection. Eyelashes and eyebrows help protect eyes from dust, dirt, and sweat. Then touch sense. Hairs can sense movements of air and touch. Warmth. When the body is cold, the erector pili muscles contract, causing hair to stand up. These hairs then form a hair trapping layer above the form a heat trapping layer above the epidermis via a process called piloerection, which is termed as goose bumps. Clinical conditions of hair. We have the first one is alopecia, or what can be termed as hair loss or baldness. Is the loss of hair from part of the body or the head. Then we have the alopecia. Still continuing with the alopecia. Alopecia causes include chemical. Alopecia causes include chemotherapy, targets all dividing cells, that is healthy or cancer cells. Then HIV/AIDS, hypothyroidism, malnutrition, and autoimmune diseases, and many others. So these are some of the causes of alopecia. These are some of the things that can make one to lose hair and have a baldy head. Nails. Nails are plates of keratinized epithelial cells on the dorsal surface of each distal phalanx. The proximal part is the nail root. Only the stratum basale and the stratum spinosum are present in the nail bed. Nail bed provide a useful window on the amount of oxygen in the blood by showing the color of blood in the dermal vessels. Clinical conditions of nails can be whitlow. This is an infection of the tip of the finger. Then malnutrition, nail beds appear pale. Then koilonychia or spoon nails, iron deficiency anemia results in abnormal fingernail shape or raised ridges. Let us look at the breast or mammary gland. Both males and females have breasts, but it is well developed in the females. The female breasts are made up of specialized tissue that produces milk and fatty tissue. Between the breast and the pectoralis fascia is a space called the retromammary space that allows the breast some degree of movement. The breast stroke mammary gland is firmly attached to the dermis by skin ligaments called the suspendary ligament of Cooper. At puberty, the mammary gland enlarges owing to increase in glandular development and fat deposition. Glandular development and fat deposition glandular development and fat deposition. Milk producing part is organized into 15 to 25 secretory lobes. Within each lobe are smaller structures called lobules where milk travels through ducts which exit the skin in the nipple. Parts of the breast. We have the apex. The apex is formed by the nipple. Nipples have no fat, hair, or skin glands. They are composed of circularly arranged smooth muscle fibers that erect the nipples upon stimulation, such as breastfeeding or suckling. Then base is the part that lies on the pectoralis fascia. Areola is the dark area of the skin surrounding the nipples. It contains sebaceous glands which secrete an oily substance that lubricates the areola and the nipples. So right there we have the structure of the nipple, or I mean structure of the breast. The nipple that I was talking about is right here, and this area has no hair. It is smooth, but once suckled by the baby, normally it becomes erectile. It erects. Then right there we have the base is here. Then the pectoris right here. Yeah, so you can see the fat deposit is also right there. Then the gland lobules, then the lactiferous duct. These are the ducts through which the milk passes. Structure of the mammary gland, we are continuing to look at it. The basic components of a mature mammary gland are the alveoli, or the hollow cavities, lined with milk secreting cuboidal cells and surrounded by myoepithelial cells. These alveoli join to form groups known as lobules. Each lobule has a lactiferous duct that drains into openings in the nipple, as we saw in the structure above. The myoepithelial cells contract under the stimulation of oxytocin, excreting the milk secreted by alveoli units into the lobulumen towards the nipple during sucking or breastfeeding. Structure of the breast at pregnancy. So during pregnancy, the ductal system undergo proliferation and form alveoli structures for milk production. After delivery, lactation occurs within the mammary gland. Lactation involves secretion of milk by the luminal cells in the alveoli. So contraction of myoepithelial cells surrounding the alveoli will cause milk to be ejected through the glands and the nipple for breastfeeding. Upon weaning, lactation stops and mammary glands undergo involution, or we can say collapse of mammary epithelial cells by apoptosis, until maybe if the person conceives again, then they develop again and she can still lactate. Breast conditions, we have gynecomastia. This one refers to overdevelopment of male breast in males. So there are some males whose breasts also develop and they become like for a woman. So that is that condition. Then we have polymastia, presence of more than two complex mammary glands. Then we have polythelia, presence of more than two nipples on one breast. Then we have breast cancer, and the breast cancer here, some humans can have abnormal division of the cells in the breast, and so they can be termed as cancerous, and because of that it can be a serious condition. Mastitis, inflammation of the breast. Then breast calcification uh, is a condition that happens to the breast because of some problem with the minerals in the body. So those are the conditions of the breast right there. Thank you so much for being part of this. May God bless you.